So I wanted to talk today about a topic that is a little bit atypical at many of the meetups that I've gone to. A lot of meetups focus on getting started with a new framework or a new architecture, a new project or whatever. And I wanted to talk instead about what if you wanted to bring serverless into, say, your own company that doesn't have anything serverless today. Are there benefits there? How could you do that? What would that look like? So I'm going to talk about some of our experiences we've had at Stackery. Again, I'm the CTO and co-founder at Stackery, where we're a platform for building secure serverless applications on AWS, helping from the design to the development to the delivery phases, basically the whole cycle of the software development lifecycle. And today I wanted to kind of talk about what if you wanted to use serverless to modernize a monolithic existing application, maybe it's 20 years old, and you want to find ways of, it could be reducing cost, developing faster, having less outages or less scalability issues. So that's what I want to focus on today. And I hope that other people are as excited as I am about this. Really quick, I assume most of you are probably highly familiar with serverless, but just in case there's someone new here, the reason why a lot of people are drawn to serverless is because they are building applications that have to do something for end users. Businesses, they're driven by creating these application experiences. They don't actually gain anything by the plumbing that it takes to put that together. So serverless is, how can we get the maximum out of building our applications and focus the least amount on the plumbing layer? A typical application you might have is made up of many different services. At least this is the case in many medium-sized and larger businesses. You might have an authentication service, a user management service, your database is over here, you've got Elasticsearch over there. These are all services you got to piece together to make your application. And in the prior to serverless, you had to construct these yourself. Even in the case of running on top of Kubernetes, you still have to figure out how to piece together Kafka as a message queuing service, for example, or how to put in a MySQL database for your database service. So serverless is all about taking those raw compute resources and allowing your cloud provider to abstract them away into these managed services where they operate it for you. They figure out how to scale it for you. They do all of that on your behalf so you can focus just on the business logic. Now, here's where it gets interesting with especially talking about existing businesses with existing applications and how serverless can be beneficial. Some of these businesses may still have applications that run inside of data centers where they're still provisioning and worrying about individual servers that they have to provision into racks physically. And when you're doing that, anytime you're adding new servers, you are effectively pre-provisioning your throughput through your system. So here, these purple triangles here, they occur when you add new servers to your system before you actually need their full capacity. So you've lost cost, basically, by pre-provisioning these servers. When you've got load that goes up and down, you're further losing on the potential savings when you have these troughs of throughput, because you can't scale things down with physical servers you own. With virtual servers that you're manually scaling up and down, you can start to approximate your throughput. And that can be simple enough if, say, the timeline, the x-axis on this chart is a matter of weeks or years. But it gets more challenging when it's a matter of days or minutes. You might investigate auto-scaling policies where you can get more finer grained. But still, there are many times where we talk with customers where they get traffic, they get it in bursts, and it's unpredictable. So they have a hard time scaling up in a matter of minutes which is what you tend to see with auto-scaling policies, where you start a server after some delay and seeing some throughput spike, and it still takes a few minutes for that server to start up and be able to handle new load. And serverless really decreases all of that scaling cost to paying just for what you need. Now, sometimes I've had conversations with people where they start to get out calculators. They do the math and they say, well, serverless is going to cost us a lot more. And oftentimes they do that by taking their peak load and they multiply it by the services they're going to need. And they find out that serverless in that instance takes maybe 10 or 15% more cost to handle the load. But they forget about dealing with the troughs and how much money they can save when your serverless service isn't running. And more so than that, you've got this production workload, but you also have other workloads, development, test, staging, that are extremely low throughput. So in older ways of doing things, or even if you're running Kubernetes, if you want to have your development team run an environment that actually replicates production, you have to spin up a bunch of instances, a bunch of virtual machines, just for them to be able to run a few requests through the system. So that's led to things where Joe Emerson, who is the founder and CTO at Branch Insurance, about a month ago, he said on Twitter, his serverless bill is just under $740, but he's done lots of startups. And at the phase where they are seeing, wow, I activated Siri on my computer and she's yelling at me right now. Sorry about that. So at the moment where they are as a startup, in similar periods in the past, they would have already been at $15,000 per month spend on AWS. So for greenfield stuff, people are saving money, but serverless isn't just for greenfield. We've got a range of customers, and MasterStream's one we like to talk about, where they lifted and shifted old apps from the data center onto AWS. And then they shifted that to serverless, and they ended up dropping their bill on AWS by 90%. So there's a ton of benefits people can see when they take existing applications and they refactor them with serverless. Part of this comes down to three core challenges with these older, oftentimes monolithic applications. And what we mean by monolithic is it's a single application type, like a Rails app or a Java Spring app or a .NET Framework app. You have one application that you auto-scale across many servers in an auto-scaling group behind a load balancer to meet your traffic. So it's monolithic because you have one code base, one application that runs to handle everything. But there's a lot of problems with that approach as you scale across many dimensions. First, when you've got scaling up of request throughput, you've got the possibility that you got 100 routes, but 2 of them are extremely costly. They take a long time to run. They use up a bunch of resources. Whatever it is, they're expensive in a compute sense. And now you have to scale out your entire cluster just for the fact that 2% of your routes are heavily utilized. That adds to your overall AWS bill. You've got a cost to your development agility because you've got teams of developers who have to share and collaborate in one code base, usually one Git repository. That gets very challenging to coordinate when you've got many projects going on. And you've got a risk and availability concern because maybe one of those routes has a bug in it, and when you went and fixed it, you introduced a different kind of bug that just took down the entire system, the entire service. So because it's a monolith, your blast radius of issues is much larger than if each bit of functionality were implemented independently. So one aspect to modernizing where serverless can come in and be beneficial is breaking apart monoliths. But modernizing is hard. I listed a bunch of reasons here, but it really, at the end of the day, comes down to you have to shift a little bit of your architectures, and you are adopting serverless, and that requires different development mechanisms, different ways of doing things. And anytime you've got a development team and you tell them you have to do things differently, it takes time. It's a barrier, but it can be worth it. And there are proven techniques to doing it. One of which in specific, I'm going to kind of demo today, is how you can use a strangler pattern. This is made famous by Martin Fowler, who talked about seeing a tree get strangled by branches of an ivy, and how that's akin to how an application can be strangled by branches of new refactoring or added capabilities that, instead of being added to the tree, are added outside of the tree as separate entities, kind of breaking it down into microservices. So we'll take a look at, through a demo, what it's like to build an application, rebuild a monolith, some of its functionality piece by piece. Through that process, you have to have new development mechanisms to help yourself as an individual developer, your teams, collaborating together. And one way that this is really important is, how do you manage all of the different services, the managed services that have to be pieced together? One way that we suggest is through a visual approach, which we'll see as well. And last, you got to have like management for environments, which helps when you've got lots of individual developers working together side by side. So we'll take a look at that too. So without further ado, let's look at a demo of this. Let's imagine we've got for ourselves this .NET framework application that's running on Windows servers inside of Elastic Beanstalk, which helps do some easy auto scaling, but it's still very slow auto scaling. You've got these application servers running on Windows with .NET Framework that are interacting with a data tier. In this diagram, it says MySQL, but in our actual demo, it'll be Microsoft SQL Server. So imagine this is just the furthest thing from modern application development on AWS. In fact, it doesn't even, I'm going to show a demo on Elastic Beanstalk on AWS, but this could even be inside of a data center that you have. So what could we do to start to break this down? We've got this application that represents a library catalog showing, listing authors and their books. And maybe the problem is that the /API/books routes don't scale well. So how can we fix that? I'm going to hop out of my presentation now, and let's hop over and look at what this application is today in the real world. This is Elastic Beanstalk running in my AWS account. And let's hit this link. At its root, it doesn't have anything because it's just an API. But we'll see that as we hit our books route, we've got a number of books that have come back to us. We've got an author's route as well. And in typical old school .NET Framework fashion, it's coming back to us in XML even instead of JSON. So this is an old school .NET Framework app running on Windows. I wanted to do .NET Framework just to get out of the sweet spot, or at least the familiarity zone that we have of everyone playing around with either Node.js or Python, maybe Go for serverless, and instead say, again, this works for the most old school applications that you've got lying around. So what can we do about this? Well, I am going to use Stackery here today, which, by the way, if you're interested, you like what you saw in this demo, Stackery is now free for individual users to use to build and manage applications. I'm going to go into here and I'm going to create a new project. So we'll call this .NET Core Web API. I already have 1 through 3. So we'll do .NET Core Web API 4. We'll put this in my Stackery organization. We'll leave it public as we're building it in case anyone wants to look. And I'm creating this application. What it's doing is it's creating a repository in GitHub with an empty SAM template. So here's the repository. Blank SAM template here. And now we can start to work on our application design. So let's imagine we're going to take, we know that we had 2 resources, or 1 resource that we needed to interact with. So that was a RDS database. So when I drag and drop resources here, it's going to start to scaffold them inside of this AWS SAM template, which is AWS's own framework. And I put in this database, and I could have it deploy a new database, something fancy like an Aurora serverless database cluster that I've got. But instead, what I'm going to do, because we already have a library catalog database, I'm going to go and grab the database from AWS. So let me hop on over and find out what my database is. So this is my .NET demo database. And I see this is the endpoint. And it was on port 1433. And so now, anytime I'm going to interact with this database, it's actually going to use the existing database. Now, to interact with it, I'm going to need a function. So this will be my web API. And we're going to write this in .NET Core 3.1. And so we'll put this at web API. And I'm going to leave a bunch of these settings here for now. So save this, and I'm going to wire it up here. When I wired this up, it did a couple of things. It gave me the ability to access the database using an environment variable. So this is using some gnarly looking CloudFormation syntax, but it basically gives me the ability to access the address of the database, no matter whether I configured it to be an existing database or I'm provisioning a new one. Makes it easy to do that. To interact with this database, I also need access to the password for the root user, and I have that stored in AWS Secrets Manager. So I'm going to wire up my function so that I can access Secrets Manager. That gave me the permission to be able to access any secrets underneath a specific environment namespace of the account I'm deploying into. So when I deploy into staging, it gives me access to environments under the staging namespace. When I'm deploying into production, it gives me access to the production namespace. To help illustrate what that looks like a bit more clearly, these are my various environments that I might have: prod, staging. I might even have individual environments for developers on my team, Nuatu and Chris. If I hop into production here, I can see that within production is hosted in this AWS account in US East 1. And inside of that, I've got a secret DB password that holds the root credentials for my database. So when I am running my code, I can ask AWS Secrets Manager for the DB password secret. So we're getting closer. The last thing I need is an API in front of this. So let's add an HTTP API. This is one of the key parts that you need as you are building a modernized strangled API pattern. So what I'll do is I'm going to create one route to send any traffic that isn't otherwise sent to a specific place to my existing API. So if I hop back over here, I'll copy this link and I'll paste it into here. So now, anytime I make a request to my API, as we have it written right now, it will just proxy that through to the existing API. But I can start to pick off other routes. So let's say any/API/books and any/API/books/proxy plus, which is the way of saying in AWS API Gateway, this proxy plus is sort of like a wild card. So it's kind of like doing that. So I'll put that in there. And now I can start to wire up these two routes to my API function. And while we've been constructing all of that visually, I now have a fully implemented SAM framework template here that will fully deploy out a strangled version of our API. So I'm going to commit this to GitHub. What this is going to do is it's also going to scaffold the that .NET framework or .NET Core web API function, basic function here. What I'm going to do instead, and I don't have time to do the full example of how to build out the code for this, I'm going to now flip over to an existing project that has the code fully fleshed out. What I did here is I took the original project, which was a .NET Framework application, and I copied over a bunch of files. So I copied over the models for our author and for our book straight over from that .NET Framework application. I copied over, or actually I ported over how we connect to our database. So here's the code where I get the value from Secrets Manager for the credentials of my database. And then I use it when I need to connect to the database to create a .NET Framework compatible connection string. And then I updated the controllers. So I've got my books controller here. I copied it over and updated it from .NET Framework to .NET Core, which is the difference between .NET Framework is it's the older version of .NET that only runs on Windows. .NET Core is the newer version that is open source, runs on Windows, OS X, Linux, and thus it can run on AWS Lambda. And it will be the official version of .NET. It'll drop the core name even, starting with the next version, .NET 5. But I converted it lightly from .NET Framework to .NET Core. And then lastly, in front of this all, I added a .NET or a Lambda entry point. So this is a bit of code that uses an AWS provided library, ASP.NET Core Server, that will automatically take an input event from API Gateway and convert that to what the .NET Core Web API runtime expects to see. So we don't have to write a bunch of logic to glue together routes and things. It automatically does the hard work for us. So now that I've done that and I ported over the books code, I can now, I'm going to pull open this, a previous version or iteration of this project that I created that I've actually deployed out to my development environment. So we can see that running here. It's that same diagram, except it's got this one random weather forecast route off to the side. Leave that aside. But now I can hop in and take a look. Here's that staging location for the API I deployed. So let's go into that. We'll see that if we go to any of the routes we didn't implement, like authors, we'll see that we get the same response back from the original implementation, the original existing API. The reason I know this is that it came back as XML, which is the default that will be returned from a .NET framework application. If I change this to the books route that we re-implemented in .NET Core on top of Lambda, we get the response in a more modern JSON format. That's the default that .NET Core responds in. So we have successfully implemented a full .NET framework application, porting it over and running it just one piece of it inside of a .NET Core Lambda function. We also have other customers who have ported runtimes entirely. So they ported from .NET to Node.js or to Python because of other development benefits that they saw by doing so. So I hope this was interesting and maybe useful for some of you out there trying to figure out how you can utilize serverless even in your day-to-day work at your own company. I want to point out a couple of things. The first is, if you want to see the full example of how this works, how this application can be refactored, I did it with some friends at AWS. And let me see if I can find it here. Yes, the Howdy, that's right, it was Howdy Partner. So this is a about 2 hour long, 2.5 hour long demo of how you can convert the entire .NET application into being that strangled, partially serverless approach. What I'll do, Gunnar, is I will send you a link to this if there's any way you might be able to share that. And lastly, if there's anyone out there who wants to try out Stackery, I just want to briefly mention again, you can sign up with Stackery for free. And if your company or anyone else wants to see more about how Stackery works, you can also schedule a demo with me, and I'd be happy to show more about Stackery and serverless for anyone interested in learning. So with that, I think that's what I wanted to prepare and give. I'd love to answer any questions people might have. And I apologize, I just noticed that Gunnar asked me if I could zoom in further, and I never saw that message. So apologize.
No worries. I think it was fine. That was no problem. All right, thank you very much, Chase. That was great. And just a few questions around this. How do companies use this when working? Is it something that you use as a team or as individual developers, or what's the common way of working with Stackery?
Yeah, so that's a great question. It's one of the challenges of building serverless applications. It's a new paradigm. It's a new way of building things. And so we started as a community figuring out just how can individual developers work together, work on a project. Now we're getting to the point where companies, large and small, are having to figure out how their teams can collaborate as they're building applications. And so one thing that is really important that I touched on and was able to demo at least a little bit is it's important to be able to go back and forth between what is hard-coded in our templates, AWS SAM templates, that can be really large. You could have examples of projects that are like 2,500 lines of YAML, declarative dense syntax. And you've got to have a way for individual team members to quickly jump into a project and understand what is related to what, what's connected to what. And in the simple example we just created, we already created about 150 lines of code there. But if you gave that template to someone, it would still probably take them a couple of minutes to figure out what's going on. Whereas if you gave them that visual overview, they would start to immediately understand what the relationship is between the resources. One of AWS's own examples here, I'm going to share my screen again, if that's all right. Oops, here we go. Yeah, so this is a 2,500 line AWS example called their connected vehicle solution. And if I copy that and paste it into boy, Siri, you really want to answer questions. If I paste that into my template here, we'll see that this is a proper sense of what is going on inside of my stack. It's something where if I was a new developer on this team and I had to figure out, I needed to fix something in, say, this IoT topic rule. Well, I could try and figure out what all is connected to what here. I might search for IoT topic rule. Oh. And there's still already like 12 of these going on in my template. And I got to figure out which is which is just a permission. And so instead, when I've got this ability here, I can dive in. OK, it's this topic rule, but maybe it's actually related to the permissions that are associated with it. So I need to actually look at this aspect of it. So even in cases where we don't fully understand how they are constructed together, the way that we do with these 20 plus of the most common resources in AWS, you're still able to visualize and understand how pieces are put together. So whether it's through a visual abstraction like this, or it's through other mechanisms that you might have, one big piece of collaborating is how do people understand the real full scope of everything that goes into a service built with infrastructure as code. So that's one of the two things I'll point out. The other is having a great system for CI/CD. So when you're doing serverless and it's based on infrastructure management, you got a couple of things you got to think of. One is traditional CI/CD is focused on code, like how your like the dependencies of your code, do they have vulnerabilities in them? Testing. So does this functionally meet verification tests? But there's also needs of how do you or colleagues, how can they work on or review an application when it's hard to spin it up individually? It's almost impossible on one laptop instead of spinning it inside of an AWS account. So ideally, you'd like to have something where you can through CI/CD, have automated mechanisms for many of these challenges. So if I hop into one of our demo APIs and I go to its GitHub repo, it's nice when you've got the ability so that on every pull request, you're going through and evaluating these things. In fact, here is where I had a failure for a dependency vulnerability. And what we did here is we went through every functional block, every code piece in the stack. We found, for example, there's a function that was called API, Logical ID API, in our SAM template. And we were able to descend into it, see it was Node.js, run npm audit on it, and see that I miscoded how the JS YAML vulnerability or dependency is managed. And so I got a vulnerability in here. As an individual developer, maybe trying to review this stack, I want to see an example of this as it's running. So I've got a preview version of this. So now I can review a colleague's code and find out, is it working? Does it fix the bug that they were trying to fix, and so on. So these are the two main things that we've found are helpful for collaboration, is having an ability for people to logically understand their infrastructure and separately to be able to collaborate on this through CI/CD.
I'm talking about architecture and visualization. That's a topic that's commonly discussed these days around serverless, given that the architectures are quite granular, more granular than perhaps what many are used to.
Yep.
So we're not seeing the infrastructure architecture that much. It's more the application design that we're seeing.
Exactly.
So having a way of visualizing that, I suppose, is better for developers, definitely. So another question then. I know you have a plugin for VS Code.
Yeah.
And can you tell us a bit about that?
Yeah. So I didn't have a ton of time today in the one example we had, but what I can do is share my screen here and show real quick what that looks like. Let's take our, did that pop up? All right, here we go. I've got my .NET web application, the same one we were looking at. I've got it here. And, oh, I kind of mucked up this plate. Let me.
Here we might need to zoom a bit.
Yeah, I'll do that in a second. Oh, yeah. Give me a second. All right, there we go. And I will zoom in a little. So I've got here my the same template we were looking at a minute ago. And inside Visual Studio Code, you can install the Stackery extension. I'll pull that up real quick. This extension makes it super easy to side-by-side edit your code as infrastructure. So if I move my visual infrastructure over here, let's say that we want to add another route. And so we'll call this, we want to start refactoring our API/authors route. And we'll see that as I start to change things in the template, it starts to modify it over here. And so now let's drop in a new function. And we'll call this our authors route. We'll make it .NET Core 3.1. We'll replace the contents on my disk and wire that up. So now I've got a new function that's fully scaffolded out. And if I look at my code base, I've got my new function here in C#. So everything that I do, this is like a nicer way to be able to run things locally as I'm developing. And then we also have mechanisms to make it easy to locally invoke functions as you're iterating on them. So I could do something like Stackery local invoke. Actually, I'm going to descend into a specific folder, Stackery local invoke. I don't have things set up, but you could imagine by invoking this, it's going to run it inside of a .NET container that replicates the Lambda environment So I have a rapid process for iterating.
That's great. So I guess that was it for questions right now. But if people have any additional questions, just ask them in Slack. And I know you might be busy after this, Chase, but we'll get back to the questions if there are any.
Sounds good.
So thank you very much for this and great talk. And the links and the link to Stacker, if they want to trial, we can post that as well. So cool. Thank you very much, Chase. Thanks for the demo.
Thank you.
And see you around.